Hello, everyone. This time, we recorded the third episode of Sentinel tutorial. After we recorded the video last time, some people left messages under our article saying that they wanted to explain some scenarios such as synchronizing MySQL to Hive. Today, I will show how to do this. First, we need to choose MySQL source. In our source section, you can find MySQL. OK, here is our MySQL connector. I will not repeat the content here. If you are interested, you can watch my first two videos. This episode mainly introduces Hive Sync. Find the Hive connector in the sync. Hive Sync has some features. For example, exactly once means that it can support precise sequential writing. In this area, we use two-phase commit to achieve precise sequential writing of Hive Sync. The supported file types include text, CSV, Parquet, awk, and JSON. Then the compression format supports LZO. Of course, for Parquet and ORC, it will support more compression formats such as SLAP. LZO is for our text and CSV files, etc. The following are some options. Let's first look at the version. I used a 2.3.5 version, but there is a bug. Well, it has been fixed in dev, so if the Hive connector is available until 2.3.6 is released, or 2.3.4 is also OK. The option introduces the Hive Sync parameters. The first parameter table name indicates which Hive table I want to write to. The second parameter is the address of the original data of Hive, of which the port address is 9083. Of course, your environment may be different. By default, the address corresponding to the port of 9083. The compress format is empty, but you can specify it. There are two configuration files, HDFS setpath and Hive setpath. This is for when we need to download the HDFS set file of cluster and place it on each node of the Sentinel engine. For example, if I deploy Sentinel with 3 nodes, I need to create a directory on each node and put HDFS set and Hive set in this directory. Then in our sync configuration file, fill in the address of this directory, which is the path of the file, into these two parameters. There will be examples below. The following parameters are hive.hadoop.conf. This is a map type where we can set some parameters related to Hive and Hadoop. Below is hive.hadoop.conf path. This parameter is duplicate to these two parameters. During version iteration, we can configure this parameter or these two parameters. If we put hive.site_path and hdsf.site_path under the same directory, we can configure hive.hadoop.conf path. In this way, it will automatically go down from this directory. Find the configuration file you can recognize. Then the next one is related to Kerberos certification. We have to fill in AKRB5_path, which is etc. KRB5, CONF by default. This is Kerberos_principal. We can put the Kerberos principal here. Well, then, it is a directory of Kerberos files. Each node of Sentinel needs to place this Kerberos config file. Then, fill in the path of our Kerberos file in this directory. Because the phase commit is used in the process of Hive being executed, it will automatically create the directory corresponding to this partition. Well, this parameter controls that when I roll back, because I may have failed the task, when I roll back, do I want to delete the partition I created? By default, it will be deleted. You can use it according to your own need. Below are the general parameters, including source, table name, etc. Well, then let's first look at the table name, which means the table name of the target Hive table. It can be written as an expression to support multiple tables. For example, in my upstream, I have 3 tables in MySQL. Then I cannot write only one table name in a representation of my Hive table. So what should I do? I can write $. This means that the database name and representation of the upstream MySQL correspond to the database name and representation of my downstream Hive. The table name of MySQL will be synchronized to Hive table. This parameter is used to support multiple table name. Of course, if our upstream is Oracle, then the table name is a schema. If we want to use Oracle's schema name as our database name, we can write $, schema name. Use it according to your needs. Well, these parameters have been introduced in detail before. I will not repeat here. And here are some examples. This case shows that if I built a Hive table and it has a partition, these 2 fields make up the partition, and I built another table, there is a Hive source. I won't introduce Hive source here again. If you are interested, you can check it out in the source connector docs. This is a configuration. Just fill in its table name. The table name in this faction is hard-coded. Let's say I will sync the table have test_hive.test_hive_source to the test_hive.test_hive_sync_text_simple. OK, a bucket is specified here. It means we can use this to set the underlying storage as S3. Then this introduces the different use of Hive in different file systems. Hive S3 is generally used in different ways. For example, Hive ignores Emma, which packages should be downloaded, and which packages should be stored in directories. Finally, it is being executed. The same is true for Hive OSS. OK, the last example introduces the scenario of multiple tables, which is to read multiple tables. Let's take a look. It can actually only specify one table _configs. One object represents a table. There are 2 tables here. It will be synchronized to another Hive table. The Hive table name is also the library and table name. Then, it will actually read this table and this table at the same time. On the target side, the data in this table will be synchronized. Of course, we can add prefixes and suffixes to this expression. Finally, it actually takes the filled stuff and replaces the variables inside as the final indication. Now, I will give you a demonstration. Well, first look at my Hive. I have created 2 tables in it. There are 2 corresponding tables in MySQL. I synchronized a Hive from MySQL. OK, this is one of the tables, and the other one is batch_MySQL_ to Doris. First, I need to clear the data in this table. OK, I have cleared the data in the table. Then let's see how to synchronize. In here, I have started a Sentinel service. Then first we have to write a configuration file of MySQL to Hive. In this job, I defined a JDBC source. It actually reads the data of MySQL in JDBC through the table list. I specify two tables, car_source.batch_m and car_source_to_Doris_stream_MySQL. Then in the second table, I only synchronize the fields in it, ID field and this field. OK. Then below is a Hive sync. We specify the table GrowJune_test. This means that the library name is GrowJune_test, and the table name is based on the upstream MySQL table name. Directly replace it. OK. Then specify here the metastore URL. Specify curb5 file, Kerberos principal file. Then I put it in this name. And then configure the Hive of set and HDSF set file path. This is written as an example. You can add any parameters you need here. OK. I will run this configuration file. OK, after the operation is completed, we will find that 1208 data have been read and written. Let's take a look at the Hive table now. You can see that there is already data in the table. There are only two fields in this table, because I only synchronized the fields. This section will be more for this table. OK. I have introduced how to sync data from MySQL to Hive. Please pay attention that before we use the connector, ensure to read the introduction docs carefully. It introduces how to use this connector. If you use the Sentinel Zeta engine like me, put the jar packages in $Sentinel_home_lib, dir. It saves us from searching for dependencies by ourselves. In the later versions, we will make more packages like this to ensure that when we use the Zeta engine, we only need one or two jar packages. You can take a look at my own directory. If you download it from the official website, you need to place the package according to our documents. Then, we can package it based on the original code. If you build the installation package based on the original code, These jar packages will be built directly. You don't need to download it yourself. Here you can see that, if I want to use it, there are jar packages of Hive and Hadoop in it. Okay, that's all for today's demo. Well, and then in the future, I hope we can build the community together. Record a demo video like mine and contribute to the community.